hopefully you have found the pattern here. The first few anyways, thinking about just what the derivative means. The derivative of 3x, again, just think about the graph. It's a straight line. The slope is 3. If it's just some general number here, the slope is m, right? If you have a straight line. If you have a horizontal line, f of x equals 3, what's the slope there? It's 0, right? Any number, okay, in general again, slope is still 0. The other ones you either looked back at when we had done them before, or you used the definition right now, but you come up with this is 2x, this is 3x squared. This one is maybe takes a while to actually expand out and stuff, and this one is 5x to the 4th. If you look at that then, the pattern, and I think I asked a few of you x to the 9th, if you did the derivative of x to the 9th, okay, if f of x is x to the 9th, then f prime is 9x to the 8th. So if we go down here temporarily and write out our rule, if we have x to the n, the pattern that I think you came up with was put this in front and then decrease the power by 1. All right, so x to the n is going to be n times x to the n minus 1. Nice and simple if the powers are positive, a little bit more tricky when the power is negative. It works even when the power is negative or you have a fractional power. So I asked you to look at these now. 1 over x is, of course, x to the negative 1. If you follow your pattern there, it says put the negative 1 in front and then decrease this power by 1. Decrease it, meaning it becomes x to the negative 2. If you write that more in the form that the original thing was given in, that's negative 1 over x squared. All right. When the variable's on the bottom, the power actually gets bigger, because of the way that rule works or that pattern works. Root x is x to the 1/2. If you follow the pattern here, you get 1/2 x to the negative 1/2, right? Because you subtract 1, you drop it by 1. So from positive 1/2 to negative 1/2, you're decreasing it by 1. And then, of course, if you write that the other way, you get 1 over 2x to the 1/2. Or, of course, 1 over 2 root x. And we actually got that earlier on in the last unit, in fact, when we were looking at slope of tangent. So that's that rule. The other rules that are here are just or some generalizations. The derivative of a constant. Okay, the derivative of a constant. If you have a constant, remember, look up here. What's the derivative of a constant? Yeah, constant just has a slope of 0. This one, maybe you're not sure. This u here is a function, not of just a variable. So the other way you could do that, I could have written this as saying c times f of x, like the derivative of the whole thing. I could have written it like that, but that looks a little bit more goofy. It's if you have a constant times a function, constant multiple of a function. As in, what was the derivative of x to the 4th? 4x cubed. What would the derivative of 10x to the 4th be according to this? Think about what the derivative is. The derivative is the slope. The slope's the rate of change. This function is changing at this rate. This function that is 10 times as big here, it's going to be 10 times 4x to the 3rd. It's going to be 10 times the derivative. You can ignore the 10. You can ignore the 10, right? You can kind of leave the 10 out. You can leave the constant out. This is the same as c times whatever the derivative of that function is. All right? If you have a constant times a function, you can kind of just leave the constant out till the end. It's a constant times the derivative of that function. Now, the other ones here. This is if you have two functions added or subtracted. So this is two functions now, u and v here. So if we have two functions to look at here, I am going to tell you what this is. If you have, let's do a little looking at this here. I need to put in one more function. Well, I already got it here. So this is, I have two functions in here. I have x squared. I have x to the third. And down here I've written the two of them combined. The blue one is the two of them combined, added together. So you have x squared, you have x to the third, and then this one is the two of them added together. If we do a tangent line, because we want to look at how the derivatives are related here. So we'll do a tangent line, which is under this one. I think we have to go line and point, and then that way. So you have those three derivatives. Now, we're just going to look at the numbers here, and of course I've got this as not such nice numbers, but oops, let's move this over here so that the numbers are a little nicer and easier to see. The derivative at this point of this function is the slope, right? So if I'm on this function over here, its slope of that is 4, right? Slope of that line is 4. The slope of this line is 12. The slope of this function, which is the two of them added together, remember it's the two of them added together, the slope of that is 16. So how are those related? You can try another point here too if you want. Oops, no, I just messed it up. We got to drag this, of course. Same thing here, right? Derivative of this. How's the derivative of the combined function where they're added? What do you do with the two individual derivatives to get the derivative of that sum? You add them together, right? To get the derivative of a sum of two functions, you add the individual derivatives. Do you see where I'm going with this? In this case here, you have the derivative of the combination of them is the sum of the individual derivatives. If we did the same sort of thing graphically, we'd get if I change it to the difference, you'd get exactly the same thing. If I subtracted the two of them, it's you add or subtract the individual derivatives. If you now that seems to be enough for. I think we should actually probably leave this for a minute here. Well, I'll actually ask you what you predict about this then. What do you predict about this? How much we got here? 483 seconds. So what do we think this is going to be? U prime times V prime? Would I have it in a separate box if it was like that? Of course not. Not that. Okay, actually we should have left that there. Not this. It's not U prime times V prime. Okay? Not that. It is U prime times V times just the function itself plus U times V prime.
To all the debate team members, there is an extremely important meeting today at lunchtime in room 246.
We're going to have to stop.